Dear students, we have already completed Unit 2. So today we are going to start Unit 3. Unit 3 consists of two parts: design of shallow foundations, in which we shall study principles of design of footing, design of isolated footings, and steep footing. The second part of the Unit 3 is the deep foundation, in which we shall go for the introduction, necessity of deep foundation, pile installation, single and double undering piles. You see that the highlighted parts, pile groups, actions of piles in sand and clay, group efficiency of piles, settlement of piles, negative excretion. These highlighted parts already we have completed in semester 5th. So this we shall not study this time. You will be having the notes. You can go through the notes for these topics. So design of shallow foundations. What foundation does? We have already discussed many things in this regard. Foundation, the construction below the ground surface is called as foundation, and the base of the foundation is called as footing. So what footing does? Footing transmits the forces and bending moment generated either due to the self weight of the foundation or due to the superstructure, right? You can see here the footing of the foundation is going to be influenced by the self weight, live load, wind loads, seismic forces. Many types of forces are going to be experienced by the structures. So ultimately what happens? The foundation transmits the forces and moments of a structure to the soil. Here we are talking foundation means footing. Footing is the bottom part of the foundation. You see that in case of shallow foundation is normally constructed up to 3 meter depth, and it can take the load of the structure based on the bearing capacity of soil. And bearing capacity of soil depends upon the shear strength of the soil, which is available below the base of the footing, right? So it is written there that only through the shear resistance, right? The second thing, the deep foundation. Already we have talked about the pile foundation, friction piles, end bearing piles, right? How the load of the structure is going to be taken by the pile foundation. The pile takes the load due to the friction resistance working along the periphery of the piles, as well as the load carried by the end of the piles, bottom of the pile, and both are going to take the load of the structure. Now we shall see that what are the various types of loads which are considered in the design of foundation. Dead loads. The dead load is nothing but it is self weight of the structure, self weight of the foundation, floors, beams, walls, columns, all will come under the dead loads. Fixed services of the equipment. Fixed services, suppose you are going to install the AC, that also will come under the dead loads. Dead load we can calculate by its size, right? And the types of structural materials. Types of structural material means what? The density of the materials. So both we can use to calculate the load of the dead parts or dead components of the structure. The next load is live load. Live load is a very moving load. We are moving on the roof of the structure. Definitely the moving load. It is not permanently attached with the structures. live loads. You are going to keep some equipments for the time beings, right? For the time being, that will come under the live loads. For example, you see people, goods, furnitures, equipment, machinery, all will comes under the live loads. And if you see the building codes, all things are given there. In the building codes, everything mentioned that which components comes under the dead load and which comes under the live loads. Next is the wind loads. All the exposed surfaces of the structures are going to experience the wind loads. So ultimately, this load is also going to be borne by the footing, right? The next is the snow loads. This also you have to consider. You see that in the winter season, the snow, suppose snow is going to accumulate on the roof of the surface of the roof. That load also we have to consider in the design of foundation, because this is also going to, the foundation is also going to take the load of the snow loads. Similarly, earth pressures. Earth pressures, we have already studied the ranking theory, earth pressure chapter. So what were the structure you are going to construct? For example, you are going to construct the retaining wall to retain the soil. So earth pressures is also going to work on the retaining wall. So ultimately, where the load is going to apply, or what we can say, which part of the structure is going to take the horizontal load of the horizontal pressure of the earth. Definitely foundation or footing is going to take the load, horizontal load of the earth pressures. So this also you have to consider. It is considered as a dead load. Water pressures. If you are going to construct the tank is the water is also going to apply the lateral pressure or horizontal pressure on the walls of the water tank. The water pressure will also be there. So that also you have to consider. Earthquake loads. When earthquake comes, it applies the loads in horizontal directions, vertical directions, right? So that loads has also been considered. It is also given in the building codes, earthquake loads. Ultimately, what I am telling you, that these loads we have to consider whenever you are going to design the foundation. And these loads are not going to apply the vertical loads on the footing, but the horizontal pressure is also going to be applied. So the vertical force as well as the horizontal force, which is also going to cause the moment. So these two things are these two things. Two things means what? The vertical forces as well as the moment has to be considered in the design of footing. What do you mean by steep footing? A steep footing we have talked many times in the classes. A steep footing is also called a continuous footing, where width of the footing is there. Width of the footing we can keep fixed, and the length may be infinite, right? So that's why we are taking the per unit length. So whenever you are going to design the footing, we are talking about the footing. Footing is the bottom part of the foundation. We are going to discuss about the design components, design methodologies. But you are going to study that in details about this topic in design of a structure 2, that is design of concrete structure. So whenever you are going to design the footings, two things we have to two things we have to calculate, two things we have to find out. What are the two things? The size of the footing, that is called as fixing base size, right? You have seen at the time of constructions in PSIT campus, column foundation. So what we have seen, the base size also there. So fixing base size, and the thickness of the footing, and dimension of the footing. That comes under the design of ST footing. So how we can design the base size? We shall see here. See, we have to know how much load is going to work on the ST footing, means wall footing. Load on the wall. Wall means what? The bottom part of the foundation. Load on the wall per unit length. You can see here, in case of ST footing, it is a continuous footing. So here we are considering the load on the footing per unit length. Per unit length. So load also we have to calculate. And the next, the self weight of the footing per unit length also we have to add it. So what we shall do? P plus P dash by 2 we shall take here. Then required area of the footing means what? How we can calculate the area of the footing? Area we can calculate load by stress. You can see A is equal to P plus P dash by small p. So P is the what? Load per unit, load on the footing per unit length. P dash is the self weight of the footing per unit length. Why we are taking per unit length? Because it is a steep footing, it is a continuous footing, right? And this a small p, which is the denominator, it indicates the safe bearing capacity of the soil. So load by stress is nothing but what? Load by stress is nothing but the area. So stress safe bearing capacity we have to find out. We have to collect the soil sample. You can find out the values of C and phi. Based on the phi, you can calculate the angular bearing capacity factors, and using the different equations, right? You can also calculate the safe bearing capacity, right? So area is equal to load by safe bearing capacity. You can see area B into 1 is the B is the width of the footing and 1 is the per unit length. Suppose the area is coming 4 meter square. So what will the values of B? The values of B will be 4, right? And 1 meter per unit length we are taking. So 4 meter into 1 meter is equal to 4 meter square. So we can finalize the area of the footing, we can calculate easily. And as I told you that the small p is the safe bearing capacity of soil and B is the width of the footing. Now, whenever you are going to construct the foundation from the top, right? The load is going to work from the top to the towards the bottom, that right? Moments are also going to work. So what is going to happen? Here it is a net upward pressure. If you are going to apply the forces from the top, all the structures are going to apply the vertical pressures on the base of the footing. So what is going to happen? The soil will also apply the net pressures in the upward directions, right? So net upward pressures can cause the bending moment and shear force, right? What is written there? Net upward pressures on footing, that is also called as net bearing capacity of soil, causing bending moment and shear force, can be found out using the above area. What does it mean? That means if you are going to construct, we shall see some figures also later on. So what is going to happen? If you are going to apply from the top, right? If you are going to apply the pressure from the top to the footing, from the base of the footing in upward direction, the shear force and bending moment is going to work on the area of the footing, right? So you shall see here what it says, that the self weight of the footing, means the bottom part of the foundation, is considered uniformly distributed, which is deducted while taking the net pressures. That means we are not going to consider the values of P dash. P dash, P dash was the weight of the self weight of the footing, that we are not going to consider here. So net upward pressure will be equal to P by. Now we can see the figure here. This will clear you all the things. So how we can find out dimension? B into 1 is equal to P plus P dash divided by small p. Using that formula, we can find out the area of the footing. And in case of ST footing, suppose as I told in the beginning, if 4 meter square you are going to find out the values of capital A. So you can take the width of the footing 4 meter and the length of the footing per unit length you can take. So 4 meter into 1, that is the area of the ST footing we can consider. Now the points here we have to talk about the determination of depth. Depth is nothing but, you remember, depth is the nothing but thickness of the footing. How we can find out the thickness of the footing in case of ST footing or ST foundation? You can see this figure. This is the bottom part of the foundation which is called as footing. Reinforcement is also there. This is the wall, concrete wall. This is a section and this is the plan. You can see here plan in the width of the column is, width of the column also you can, the width of the wall is a small b and the total width is capital B, right? And the per unit length we can consider for the design purpose. Next figure you can see C figure, net bearing pressure diagram. How the net bearing pressure, net ultimate bearing pressure is acting in upward directions because the load is working in downward direction. A structure load is working in downward direction. So what will happen? Net bearing pressure generated due to the soil will work in the upward direction. So here we have to calculate the maximum bending moment diagram. We have to draw this is the maximum bending diagram. So here you can see along the face of the wall, right? The bending moment is maximum. This is the bending moment. Okay. So how we can find out the thickness, this thickness of the footing? This you have to calculate because this thickness is going to take the load of the structure coming from the top, right? So this thickness we have to decide. So two things are there. We shall go for bending moment consideration. Bending moment generated due to superstructures, right? So on the superstructure on the footing. So bending moment consideration. Using the bending moment consideration, we can finalize the thickness of the footing and the shear force consideration. Two things are there. We shall discuss one by one. So design bending moment at the face of the wall. As I told, the face of the wall. This is the face of the wall, right? What is the bending moment? Moment, moment is equal to force into distance. So force is nothing but a stress into area. What is value of a stress? A stress value will be rho. Net ultimate bearing pressure is nothing but a stress. And how we can calculate the area? The PO is the net bearing pressures and B minus B. You can see here total width is B. You are going to subtract the values of small b. So B minus B by 2. By 2 means what? It is, suppose this is the width, so B minus B, this is the B minus B divided by half, right? We can take as a B minus B by 2 into the area. Per unit length we can take, so B minus B by 2. This will be the width for this in this case, and the per unit length we can take. So B minus B by 2 into 1. Per unit length we are taking, so this will be the area, this will be the stress, and this will be the distance. You can see distance. Distance means what? B minus B divided by 2 is this total length from here to here. But if you are going to take the moment here along the face, B minus B by 2 by 2, that will be equal to B minus B by 4. So this will be the distance. The total moment will be PO by 8 into B minus B whole square. Here actually it is the typing mistake. PO by 8 will be there here. You can see PO by not 2. This 2 will not be there. PO by 8 into B minus B. So this is the maximum bending moment. So I think we have completed the all the slides and how we can find out the dimension of the footing, right? Steep footing. and its thickness. These are the components of the design parts. So as far as the different formulas are concerned, like RB, KB, JB, lever arm factor, this details about this you will study design of structure too. But as far as the foundation design is concerned, you have to know the procedures, how we have to design the steep footing, considering the bending moment and shear force, and how we can finalize the dimension of the footing and thickness of the footing. Okay, thank you. I think it is. You can see how we can understand the clear cover and the effective cover. So this is called a clear cover. So what we have to do for the total depth, this capital D small d is different. I have taken the figure for your clarification only. Don't think that D is the previous slide D is the same D. It is not like that. This D is also different. Here this figure I have given you for your clarification, that clear cover means the outer side of the reinforcement, and this the, the plaster part also we can, for understanding you can say the plaster part. This is called a clear cover. Okay, and this is called an effective cover. So the total